Suppose f is the differentiable function shown in the accompanying graph, and that the position at time t in seconds of the particle moving along the coordinate axis is given as the integral of f. Okay, so that's the graph of f. The integral of that, going from 0 to some time, tells you the position. Okay? So what is f representing then?
Position.
F is the velocity. This is the velocity function. Because the integral of the velocity gives you out the position, right? An integral is an antiderivative, or an integral gives you a displacement of the antiderivative function, right? So it's telling you, it's giving you the displacement of the position. So that means f is the velocity function.
So is it just 2?
So what is the velocity at time 5?
2.
2. F of 5
Just 2.
is 2. What are the units on it?
We don't know.
It doesn't tell you.
It says meters at the bottom.
Meters per second.
Meters per second is velocity.
Wait,
What does it mean by justifying?
Wait, so now you take the
I mean, we're justifying it by
Like, show your
saying
work.
f of x is the velocity function. That's the justifying.
For acceleration.
Part B, is the acceleration at time 5 positive or negative?
No, you take the derivative again.
Negative, because the slope's negative.
Yeah, so acceleration is f prime, right? So it's the slope of that graph. So in this case, it is
Negative.
negative because
The slope of
f has negative slope at time 5. Okay. What is the particle's position at time 3?
Oh, that's a 3.
So that's when we have to do the antiderivative. Or the,
No, it's
that
positive.
we have.
What's the formula for position?
The antiderivative.
What's the formula for position?
The
The integral from
0.
0 to 3 of the f function. What does that mean visually?
Area from 0 to 3.
The area under the curve. If we knew the equation, we could do the antiderivative and evaluate it from 0 to 3. We're not given the equation. We could figure it out because it's a line. So it's up to you. If you want to come up with the equation of that line and do it algebraically, you can. Or if you want to do it geometrically by finding the area of the triangle, you could do that. I think the area of the triangle is easier.
Yeah.
Okay. Area of a triangle is what?
4.05.
1/2
base times height.
base times the height. So
What's the height?
4.5 or 9/2. What's the units on it?
Meters.
Meters. We're talking about a position. At what time during the first 9 seconds does S have its largest value?
Or S.
Wherever the slope's the greatest.
What is S representing again?
Position.
The position. How do we find it?
Integrate.
Integrate. So visually, what does that mean?
Greatest area.
The area under the curve. So at time 6, we're adding on area, 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 we're adding on area. Oh, now we are taking away area, taking away area, taking away area. Right? So where is it going to be the biggest? At time 6. Because the area, or you could say because the integral from 0 to 6 of f of t dt is positive on the interval, 0 to 6. Right. You can say it like this: the integral integral from 0 to t of f of t dt is positive from 0 to 6. Like that, like it's getting bigger and bigger and bigger. Right. And you could say, after time 6, the integral becomes negative. So what does that imply? What does it mean that the integral became negative? So the position is decreasing.
Would that,
Because the area, the space under the curve or the integral is telling you how the position is changing. So if it's positive, you're increasing the position. If it's negative, you're decreasing the position.
Could you just say that the integral from 0 to 6 is positive and the integral from 6 to negative?
wait, for the next one, would it just be when the slope's 0?
Approximately, when is the acceleration 0? So when is the slope 0?
4 and 7?
Okay, yeah. Because the slope of the velocity is 0. When is the particle moving toward the origin? When is it moving away from the origin?
At 6, it's moving toward.
From 4 to 6, it's moving towards?
From 1 to 4.
I think 4 to 6.
Okay, where's the particle starting in the beginning?
0.
How do you know it's starting at the origin?
Probably down.
Because that's what's on the ground.
Because the integral is
That's
from
an
0.
x function.
Integral is from 0 to
That's a
6.
graph of an x function, a velocity function. It's not a position function. How do you know?
Because the integral is from 0 to the position.
Okay, the integral is from 0 to t. Okay, so the position tells you the integral. Sorry, the integral tells you the position. So at time 0, 0 to 0, you would get out 0. Okay, so the particle starts at the origin. Then what happens?
Moves
It moves away. For how long?
to 6 seconds.
Till time 6 seconds, right? We said it's positive, 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 positive area. It means you're moving to the right, moving to the right, moving to the right. The parts where it's getting taller and taller means you're moving to the right at a faster rate. So this is like what you're doing. Pretend this is the origin, okay? So in the beginning, I'm going really fast, and then I'm slowing down. But I'm still moving to the right, okay? After 6 seconds, what do?
Turn around.
I turn around.
So on 4 to
And I'm moving away really, really fast, and then not as fast.
So
And
it's
at
4 to
9 seconds, I turn around again. You get it?
So is it from 4 to 9 or 4 to 6?
So
Zero,
there's
one
two questions.
step.
When are you moving away towards the origin? You're moving toward the origin from when?
6 to 9.
From 6 to 9. And when are you moving away from the origin?
0 to 6.
From 0 to 6. On which side of the origin does the particle lie at time 9?
What? Which?
On which side of the origin?
Like above or below? Is that what you're asking?
On.
It's a particle that is moving along the coordinate axis, s of t meters. Okay, so let's say here's the origin. Okay, at time 0 you start here. We said for 6 seconds you do that, and then from 6 to 9 you turn around and you start going the other way. The question is, do you go past the origin?
No,
How do you know?
the area is still smaller.
The area is smaller, okay? So you would say the integral from 0 to 6
It's greater.
is greater than the integral from 6 to 9. In this one, you're moving, away from the origin, right? Or in the positive, let's call it in the positive direction. And in this one, you're moving in the negative direction. But since the positive direction area is bigger than the negative direction area, you're going to end up being positive side of the origin. You guys understand that? So this space in here is bigger than this space here. So the displacement or your movement in the positive direction will be more than your backstepping. Good? Okay. Before I make you turn in the front side, let's talk about your homework. So if there's any questions on that, we can address that. And then if there's something that you weren't sure about from the drill, you could maybe go back and correct that. Okay, number 1A was negative 13 over 3. B was 2 root 3 over 3. Number 2 was 15 over 4. Number 3 was 710 over 11. Number 4 was 20. Before I move to the back. What?
Number 4.
Number 4, yeah. Okay. Find the area of the region bounded by the graph of y equals 1 plus the cube root of 3, cube root of x. X equals, I know I'm copying it down, it's on the paper. Okay. Just do it. All right. So, 1 plus the cube root of x. First of all, do you know what the cube root function looks like? Okay.
Like this.
Looks like this. Okay. And when you add 1 to it, it gets shifted up by 1. Okay. So, doing something like that. Okay. And this says it's running from 0 to 8. And then y equals 0. Okay, so when I plug in 0 into this, I get 1 plus the cube root of 0, which is 1. So that's where that's heading. Okay. And then when I plug in 8, what's the cube root of 8?
2.
Cube root of 8 is 2. 2 plus 1 is 3. So this is at 8, comma 3. And then y equals 0 is just this horizontal line. So I want to know from here to here and here and there, I want to know what that area is. That's what it's asking for. Right? Okay, how do you find area of a region?
1 over 8 minus.
It's not asking for an average value. It's just saying find the area. So it's just the integral.
So from 0 to 8.
Integral from 0 to 8 of 1 plus the cube root of x. That's all it's asking for. Find that integral. Make sense? It's not asking for an average value. Okay. So from 0 to 8, 1 plus x to the 1/3 is another way of writing that. Okay. And then the antiderivative of 1 is x. Antiderivative of x to the 1/3 is x to the 4/3 over 4/3, or times 3/4, running from 0 to 8. And then you plug in 8, so it's 8 plus 3/4 times 8 to the 4/3. And then minus plug in 0, that's just going to give you 0. You don't have to do 8 to the 4th and then cube root it. You could cube root it first and then raise it to the 4th. So the cube root of 8 is 2, then 2 to the 4th is 16, and 16 divided by 4 is 4, and 4 times 3 is 12, and 12 plus 8 is 20. Got it? I'm just going to read you quickly the answers, or do you have the answers? I don't know why I'm reading the answers. Guys, stop me next time. Okay, did you have other questions from the homework though? You do? Which, like on the back or more from the front? One's on the back? Okay, so I'll take time to go through it next time. Thank you. Okay, I will take your drills, please. You can't just finish this problem. I said you can use a calculator. Just finish it. Use your calculator.
Oh, we did. I don't know why I just didn't write it down.
Mystery, did you
Yeah.
have that
Are you there?
section?
What?
Tonight.
I didn't finish checking.
Wait, I did it with
You want to just take them and show them to me next week, or you want me to hold on to them? Hold on to them? Fine.
I did it. I don't know why. I was using it.
All right, have a good Shabbos, guys.
Maryland comes out today for the people that apply.
I heard.
Turk Nation.
Okay. The turf, always the turf.
Yeah.
Did you guys all apply to Maryland?
I didn't, but I visited with Jonah. You're gonna love this. You're gonna hang this up in your room. You're gonna hang this up in here. I'm gonna be glad to serve you in the turtle.
Fun memories.
Bye.
Bye, guys.